Well, here's the thing. If you're going to solve it, if I use the bottom equation to make my key, I'm going to be dividing 15 by 2, which inherently creates extra fractions. I want to avoid it. The easier approach is to take the top equation and solve it for y, because there's no number there, but you want to watch your signs. The sign is what's going to make it challenging. Dan?
I forgot there were fractions on the things. That's why I'm like, okay, this can't.
Yeah, well, then again, the advantage of these worksheets, always remember, is you want to look at that answer bank to see where you fit. And you've got some hints that you're going to have some answers that work out with fractions, girls.
So you're going to times it by positive 2, right?
Well, I'm going to take this top equation. So 6x minus y equals negative 4. And I think the best strategy is to isolate that y. It's going to be the easiest to get because I'm not going to create fractions. So I'm going to subtract 6x from both sides. And this is also where a lot of mistakes happen. What happens to this side of the equation when I subtract off the 6x? I'm left with a negative y.
Wait, don't you have to make the y's the same first?
No. When you're doing solving by substitution, you don't have to solve them both for y. You just have to get one equation to be one variable equal stuff. You want to create the key. Hang on. So that's what I'm doing here.
What are these problems called?
This is solving by substitution. Now, this problem, I'll be honest with you guys, would be a lot easier if I could solve by elimination, because I could just multiply this top equation by 2, which would give me a negative 2y, and then squish.
So you can't do that?
Can't do that because the problem's actually called for me to do it by substitution. So now I've got this, and now as Rudy said, I can divide each side by negative 1.
Are we getting our key right now?
Yeah, we're getting the key. And that gets me the y by itself. Solving by substitution requires that you find a key, which is one variable alone equals everything else. So it's 4 plus 6x. When I worked with students on this in class the other day, this was the hardest problem, the first major hard problem, because a lot of students either forgot that negative, they didn't divide it right over here, or in many cases they tried to use this equation to get x, and then they had all these crazy fractions going on. And again, you don't want fractions if you can avoid them. Keep everything in whole numbers, life is easier. So now I'll take the second equation, 2x plus 2y equals 15. And now I'll substitute in the y. So 2x plus 2 quantity, 4 plus 6x equals 15. And there I've done the substitution. I've replaced y with what y equals. And that's all substitution is. Yeah. So this is number 8 from the homework. And of course, the problem we also run into, and again, working with students, I see a lot of mistakes in this part. Strange things happen. Little mistakes, forgetting to distribute across both of those. So 2x plus 8 plus 12x is going to equal 15. I worked with a student earlier today that I think it took us 9 tries to get through a problem because there were just little mistakes pocketed through the whole every step of the problem. One little mistake here, another little mistake there. So take your time and take advantage of the answer banks when they're offered. Can I clean this side of the equation up?
Yes. Put them together and it's 14x.
Okay, yeah. Combine like terms, 14x plus 8 is 15. Subtract the 8 from both sides. Leaves me 14x equals... No? Yes. Really? Oh, wait, it's the minus 8, that's why. 7. And then divide by 14. And I'm left with a fraction. X is a half. So now I can go back to my key, which says that y is equal to 4 plus 6 times x, and x was a half. So that's y is equal to 4 plus 3, or 7. So my final answer, 1/2, comma, 7. In the grand scheme of things, most of these problems that have fraction answers aren't that bad. You just kind of have to muscle through them. And I'd like to say you don't ever have to worry about fractions on these, but you have to be able to. We can't turn everything into decimals. The fractions shouldn't be deal breakers. So you want to take a look at that.
Have we ever used decimals in that?
You can, and it'll work. You can make this 0.5, and on your calculator, 6 times 0.5 is still 3. But again, what's nice is when I plug in the half, 6 times a half works out to a nice, neat number again. And that's true for most of these problems. They're not written to make the fractions the hard part. The fractions are just there to add a little more complexity. Although I personally think this part here is still way harder, dealing with that negative. Okay.